The SAS demonstration video, Character, introduces you to character functions and how they can be used to take apart character strings and also to concatenate character strings. In this first example, we are going to start with three variables: first name, which is going to be called fname, last name, which will be called lname, and middle initial, which will have the variable name mi. From these three variables, we want to create a new variable called full name. And notice that our first three variables are all in capital letters, and in our new variable we want to have that character string have lowercase letters. So we're going to use character functions to create this new variable. So we are going to start by creating a SAS data set called names, and we're going to read in our variables in stream data. And notice we're using the option DSD, which tells us that our data is comma delimited and that consecutive commas would indicate a missing value. Here is our data. We have three observations that we're reading in. We're going to start with an informat statement to override the default 8-character limit for character variables. So normally if you read in a character variable, it has an 8-character limit, and we are overriding that default by using the informat statement to give a new length to each of these variables. Then we're going to input the three variables, lname, fname, and mi, and each of these variables were separated by commas. Then we're going to have a length statement to set the length of the new variables that we're creating. So we're creating three new variables: fname mix, which is going to have a length of 20, so it's going to be a character variable with a length of 20; lname mix, which is going to also have a length of 20 and is a character variable; and finally full name, which is going to have a length of 44 and is a character. Now the first thing we want to do in our program is we want to take the first character from the first name and concatenate it with lowercase values of the second through last characters. And then we want to do the same for our last name. So we're going to call our first variable fname mix for the first name. In this case, if we were to look at our first observation, Elizabeth. So we want to take the E off of this name Elizabeth, the capital E, and then we want to concatenate it to the lowercase letters of the rest of my name, Elizabeth. So here we're taking the first name, fname, and we're using the substring function to take off the first letter. Then we're using this concatenate operator, which is two parallel lines, and then we're using a function within a function. We're taking the substring of first name starting with the second character all the way to the end of the name, and then we're going to take the lowercase of all those letters. We're going to do the exact same thing with the last name. We're going to take off the first letter of the last name and concatenate it with the lowercase letters of the rest of that name, lname. And then finally, we want to concatenate the new first name with the middle initial, including the period, and the new last name. And we're going to do this also using this function compbl, which removes any extra blanks that were there because of our length statement. So we are creating our new full name using this compbl function, and then concatenating fname mix with the middle initial, with a period and a space, and with the last name. And remember, we want the middle initial to stay as a capital letter. So we've done a lot of interesting things in this data step using character functions. Let's see what happens if we run all of this code now. So here are our original first and last name and middle initial. And here we're printing out our new variable full name. and the variables we created. So here we had the fname mix, where we had taken off the first letter, left it capitalized, and then the remaining letters we used the lowercase function to turn it to lowercase. Did the same thing with the last name. Here's our middle initial, and here's our full name. So this is one variable, full name. It's a character string with a length of 40. So if we go back and do a proc contents, we see here that our lengths reflect our length statement and our informat statement. And notice here that the contents procedure shows up first with an alphabetical listing and then the variables in the order that they were created. And the way I was able to do that was in the proc contents procedure, I used an option called position, which not only prints out the variables in your data set in alphabetical order, but in addition prints it out in the order in which the variables were created. So based on the input statement and then the new variables that we created in the data step. The other thing I wanted to point out to you is I wanted to show you what happens if we created full name without using the COM-PBL option, so you can see the difference and how this function removes the extra blanks that are there because of the length statement. So let's rerun this and look at what happens when we leave out the COM-PBL or combo function. Notice here that full name is spread out because this is actually a character string of a length of 44, so all these extra blanks were left in to reflect the length of the character string. So what the function combo did was it removed those extra blanks, and that's why here full name looks the way we want it to look. In this next example, we want to go the other way. We want to start with one variable for the full name, and we want to separate variables for first name, middle initial, and last name. So we want to start with one variable and create 3 new variables. In this example, we're going to make use of the scan function, which picks off words from a character variable. We are going to create a data set, names, and we're going to read in these 3 different full names. So this is one variable that we're reading in. And first of all, we're telling SAS that this one variable, full name, has a length of 44. Notice you could also have used a length statement here instead of the informat. But that must come before the input so that full name is read in correctly. So we're going to input full name, which is a character, so we're showing the $sign. And then we're going to give a length statement to the new variables we are going to be creating, fname, lname, and mi. Remember, the length statement always needs to be placed before we create the variables that are reflected in the length statement. So we're defining the length of the new variables we are planning on creating. And so then, this is a little bit simpler than our previous data step. We're going to take fname and we're going to scan our full name for the first word. And a word is anything that's separated by a delimiter. And so there are certain default delimiters like a space or a period. So here we're going to first of all just scan for the first word that appears before a space. In the second situation, we are going to create a variable mi, and we're going to scan full name for the second word where space is the delimiter. And I need to put in this quote, space, quote, to tell SAS that the delimiter we are looking for is a space. If we didn't include this in there, then it would also look for a period as a delimiter. And I'm going to show you what happens when we run the code without that example. And then finally, we're going to scan our full name and pull off the third word. So let's run this code and see how it works. So here's our original variable, full name. So this is a long character string. And we've created 3 new variables, fname, mi, and lname, by using the scan function. If we do proc contents, again we see that our character variables reflect the fact that we had used a length statement to define them. Remember, if you don't use a length statement, then character variables are automatically 8 characters wide by default. They automatically have a length of 8. Let's see what would have happened if we had not had the quote space quote for defining mi. So I'm going to comment out this first way of defining mi and show you the output. So notice here what happened is with the scan function, without indicating what the particular delimiter was, it only pulled off the initial. It didn't include the period. So what we were doing in this first way of defining mi is we were saying that our delimiter was just a space. So the period was included as part of the word. The substring function is very helpful for extracting substrings from long character variables. So let's say, for example, we have an ID number. And the ID number is NJ12M99, which contains a state abbreviation as the first 2 digits and a gender code as the 5th digit. You might also want to extract digits in position 3 and 4 as a numeric variable also. So I'm going to show you how to do this with the substr and input functions. And so here is an example that actually could happen with some medical data, where you have several pieces of information in one character string, and you want to separate out that information, and you may want to even take that information and convert it to a numeric variable. So I'm going to create here a SAS data set called extract. And I'm inputting just one variable ID, which is going to have a length of 10. So I'm using a colon modifier and giving the informat a length of 10, and it's a character string. Notice I'm using the double trailing ats to tell SAS that we're reading one variable repeatedly after the next variable in a single line. This is a convenient way of reading in data where you only have 1 or 2 variables per observation. Then I'm including a length statement, and I'm saying that state is going to be a character variable with a length of 2. Gender is going to be a character variable with a length of 1. And last is going to be a character variable with a length of 5. So the first variable we're creating is called state. State equals the substring of our ID. We're starting in position 1 and reading off the first 2 digits. ID number, we're going to have a function within a function. So first of all, we're looking at our ID, starting in the 3rd position and pulling off 2 digits, and then we are going to use the input function to make these 2 digits a number with the informat 2 dot. So it's going to be 2 digits wide with no values to the right of the decimal point. Gender, we're just taking the ID and pulling off from the 5th position 1 digit. And then finally, last, we're going to take the ID and from the 6th position to however much is left in the ID variable, we're taking off all the remaining digits. So we have here 3 different IDs that we're reading in, and notice they're of different lengths. Okay, so let's run all of this code and see what the printout looks like of these new variables that we have created using the substr function. So here's our output. This is the original variable that we read in, ID, which was a character string. From that variable, we created ID number, and we used the input function and the substr function so that the ID number is now a number. Then we took off the 2 digits 1 and 2 of our ID variable, which was the state. The 5th digit that we took off using the substring function was gender. And then the remaining digits from position 9 to the end of the variable ID was the variable last. Now, although last looks like a number, this is actually a character string. The difference being that when we created the variable last, we did not use an input function. We just used the substring function. How else could you determine whether ID number and last are either both numeric or whether one of them's character and one of them's numeric? How would you find that out? You could do that with the proc contents procedure. So I'm going to type proc contents, and then I'm going to run this procedure and see whether these variables are character or numeric. So I want to check this because, of course, if they are character, then we cannot do any kind of mathematical operations with them. So here are the output from the contents procedure, and we see here that gender is a character, that 1 digit. ID, which was the original variable we read in, was a character string. Last, which was the numbers taken off at the end of the string, is a character. State is a character, and ID number is a number. And the reason again that ID number is a number is because we use the input function, ID number equals input, and then we took the substring of that original variable ID. The last thing I want to show you is how we can use the index function to locate the position of one string within another. And this function returns the starting position of the substring you are interested in, or it returns the value 0 if the substring is not found. So we're going to create a data set called temp, and we're only inputting 2 variables, name, which is a character, and it's in columns 1 through 12, and then the age. So we're actually doing a mixed style input here where we're using column input and also list input. And we're reading in 5 different observations. So let's just run this code. It's very simple, practically like what we did in the introductory demonstration. Now let's say we were interested in the observations where the name Harvey, H-A-R-V-E-Y, appears somewhere in the name. So we're going to create a new variable called x. X equals the index of our original variable name, and we're looking for the position where the name Harvey is in that character string. So we have this variable called name, and we're interested in this combination of letters and what's the starting position of those letters in that character string. And so what x is going to equal is it's going to equal that number of the position of the substring, or it's going to equal 0 if the name Harvey is not found in that character string, which we're calling name. So let's take a look at what happens if we print out this data set temp1. So here you see these were the original variables in our data set, name and age. And notice that x has different numeric values. So for the first observation, x equals 1, and that's the starting position of the word or the character string Harvey, H-A-R-V-E-Y. In the second and third observation, Harvey doesn't appear, so x takes on the value of 0. In the fourth observation, Harvey is in that character string, and it appears in the 7th position. It starts in the 7th position, and so x takes on the value of 7. And then in the last observation, Harvey, notice here it's spelled H-A-R-V-Y, so again x takes on the value 0 because it's only looking for the character string H-A-R-V-E-Y. That's the character string that the index function is looking for. Let's say we were interested in just printing out observations that had Harvey in the name. So we can use a where statement in our proc print procedure. And the where statement is saying where x is greater than 0. So we are only interested in observations where when we use the index function, it returned a numeric value which was the position of the starting point of that character string Harvey. Also, I want you to notice that you cannot use an if statement in a procedure, but you can use a where statement. So here you see that only the two observations Harvey Smith and James Harvey are included in this proc print where we had a where statement. And these were the two observations where Harvey was found in the variable name. The index function is helpful with health data where medical conditions are diagnosed and expressed as character strings, and you want to pick out the patients who have that particular condition. So you can use the index function to determine if a certain diagnosis that is embedded in a character string appears for a particular patient. I have actually used that in some of the research that I've done. So the index function is a very useful character function. This completes the SAS demonstration video character and how we can use them to take apart character strings and also concatenate character strings.